Hello everyone. This video will show how to write the equation of a polynomial graph with multiplicity. Now let's go over this example. In this example, we are going to identify the roots of this given graph. So I've labeled the roots of this graph. Roots means where does this graph cross the x-axis, or pretty much like the x-intercepts. Now if you look at the graph, of the three roots that we have here, if you notice, the graph bounces off at this point here. Please remember that if a graph touches and bounces off at that point or at that given root, the multiplicity on that point is even. So that would have an even multiplicity, 2, 4, 6, 8, 10, and so on. So I'm going to go ahead and write that description up here. So again, if the graph touches and flattens on that particular root, then there is an even multiplicity. So that means that would be 2, 4, 6, 8. So we go ahead and write the roots for this given function here. So the first root that we have here is x equals -3. Then we also have x equals 1 and x equals 3. Now again, please remember that there is a multiplicity on x equals -3. We are also given 2 points, -2, -30, and 0, -54. So I'm going to go ahead and write that down here. So let's go ahead and set up the equation for this graph. So we start writing y equals a. Then we're going to use the roots that we have here. So the first one would be x plus 3. And then we also have x minus 1, and we have x minus 3. Now, please remember that there is multiplicity on x equals -3. So this one right here will have an exponent of either 2, 4, 6, 8. But for this problem, let's try 2 first. We are going to check our work if 2 works for this problem in a little bit. So we go ahead and determine the value for a. In order that we can do that, we're going to use one of the points. Let's say this first point right here. We're going to take this as our x and our y. So what are we going to do is we plug in -30 to the y, and we plug in -2 to all of the x's to solve for a. So this is how the equation is going to look like. So what I did was I plugged in the y value, which is -30, and -2 to all of the x's. So I'm going to go ahead and simplify this to solve for a. Since we wanted to solve for a here, we're going to divide both sides by 15. Divide this by 15 so we can cross that out. We could go ahead and say that our a value, or the stretch factor, is -2. So what we do now is to plug this -2 into that equation that we have right here, which is a, and that would be the equation for this graph. So the equation for this graph would look like this. Now we are going to check our equation whether this equation works for this by using this other point here. So I'm going to show the work on the side here. So we're going to have 0 as our x and -54 as our y. So I'm going to go ahead and rewrite this equation up here. Now we are going to plug in 0 and -54. Now, if you look at the math here, both sides of the equation equal -54. So that tells us that this equation is the equation for this graph that we have here. So that is how we write the equation of a given polynomial graph with multiplicity.